The last thing we're going to look at is really an application of our rules of logarithm, and that is looking at how to change the base. So we do have a change of base formula, and we're going to go ahead and derive that, understand where it comes from. But the reason we have it is because most calculators can really only compute, and you'll see on your calculator the symbol log, which of course represents base 10, or ln, which is log base e. So all these examples, if we have like log base 2 of 3, we didn't know how to do that because it wasn't one of these. So what we're going to do is just consider a general value. Say you are looking at something like y is equal to log base a or b. Let's go ahead and do b, even though our book uses a, just to keep in mind that that b represents the base of x. So what we could do is switch this to its exponential form. So doing that, you'd have b to the y is equal to x. So now, realize that this logarithm that we've been dealing with is just an example, or it's just a function. So we've dealt with things like x squared plus, or x squared equals 9, and we've taken the square root of both sides. That is to say, we've applied the square root function to both sides. So it actually makes perfect sense to just go ahead and do that here. Let's go ahead and just apply log base whatever we want. So let's just say a to both sides. So what I'm going to go ahead and do is I'm going to slide this over and make some room. And what we're going to do is just say, okay, I'm allowed to take each side as the input to say log base a. So you'd have log base a of b to the y and log base a of x. And now this y could come down in front. So you have y is equal to log, or not equal to, let's try that again. Come down in front, it means power rule, so it's to be times log base a of b is equal to log base a of x. And then, hey, I can solve for y again. By just dividing both sides by the log base a of b, it goes down here. And then we have simply that y is equal to log base a of x divided by log base b, or log base a of b. Notice that in the original expression, x was on top, or higher than the b, so it makes sense that it actually stays here. And b, the original base, is now the input to our changed base. Of course, the way we're going to use this most often is when it comes to applying it to the common log or to the natural log, because then we can use our calculators, our numerical tools, to go ahead and simplify from there. So in summary, let's say we have, let's slide down here. We have log, and let's say we have base b of x. The change of base formula says, you know what? I can take the input x and apply it with a new base, as long as I take the initial base and also treat it as an input to log of our new base. So this was base a. The most common one we'll probably want to deal with is with either log or log base 10 or ln log base e. So just to write that out, you can say our original log base b of x is just log of x over log of b. So this again is base 10, it's our common log. Or, and again, notice I'm writing equal, so it doesn't matter how you do these, because when you simplify it, it'll all come out numerically to the same thing. And say last thing we wanted ln of x divided by ln of b. So this here is base e. So here we have this expression in example 3. We want to go ahead and change log base 5 of 13 to something dealing with common logs. So again, just log base 10, or the natural logs in log base e. So log base 5 of 13. Can't type that in a calculator or anything, but change of base says I can convert this in a, we're doing the common log, to log base 10 divided by log base 5. And if you were to type that in a calculator, what would you find? This would be approximately equal to, so again, make sure you do the top and the bottom and then get those values and divide. You'd get approximately 1.59. And in the case of B, we want to go ahead and apply with natural logarithms. So we'd have log base 5 of 13, that's our initial value. Well, go ahead and type in your calculator ln of 13, then divide that value by ln of 5. I encourage you to pause the video, try it, because what you should get the exact same value of 1.59 approximately. So these are several different properties of the logarithms that we'll use to solve equations. So take some time, really understand where we're getting them and how to use them, and keep up the good work.